Let's look at the technique of integration using partial fractions. Okay, so before we actually look at how to integrate these fractions, we need to know how to write them in partial fraction form. So if you look at these integrals that I've written down, the first one, if we were asked to integrate 2 divided by x plus 1 times x minus 1, hopefully your first instinct would be, well, it's a fraction, so I'm thinking maybe it's going to turn into a natural log in ln. But you can see that because we've got a quadratic on the bottom, the derivative of a quadratic would be a linear function, and there's only a constant on top. So what we'd need to do if we were asked to integrate something that looks like this, we would need to write this as 2 separate integrals. So because it's something divided by x plus 1 and x minus 1, we could split it up into something over x plus 1 and something else over x minus 1. Then we could integrate these two separate, because that would become an ln. Like if you differentiate a linear, you get a constant. So you could that would become an ln integral that we could work out. Okay, we'll look at how we split it up in a minute. This next one, again, we've got a quadratic divided by a linear. Now you might think, oh, is it going to be an ln? Differentiate the bottom, you'd get 2x, but you've got 3x minus 1. There's 2 separate terms on top. So instead we could write this as something over, now if you look at that denominator, it's x squared minus that, it's a difference of 2 squares, so that's x plus 3 times by x minus 3. So we could write it as something over x plus 3 and an integral of something else over x minus 3. Okay, this next one we've got to be a little bit more careful, because this is what we'll call a top-heavy partial fraction. Now if you've got a quadratic divided by a quadratic, like think about what this fraction says. This fraction, if you divide something by something else, it's the same as doing a division, isn't it? A fraction essentially is a division. Now if you divide a quadratic by a quadratic, you will get a constant. Then we would also get, because of this quadratic, x squared minus x minus 6, we can factorise into x minus 3, so it'd be something over x minus 3 and something else over x plus 2. Okay, so if it's, you've got to, when you get a question like this in the exam, first of all, you've got to realise, well, I need to split it up into partial fractions, and also you've got to think about what form it would look like. And this will take a bit of practice, guys. Okay, one last one. Think about this. You've got a cubic. Divided by a quadratic. So if you do a cubic divided by a quadratic, you're going to get a linear function. So because it's definitely a top-heavy one, there's a higher power of x on the bottom, you would have ax plus b, and then you would have something over x minus 2 and something over 2x plus 1. Okay. Sometimes the form is given to you in the exam, but it isn't always, so you do need to be aware when you get these fraction integrals that you're probably going to have to split it up and write it in another form, and that technique is called partial fractions. Okay, so let's try a couple of examples from the handout. So example 1 is the integral of x minus 5 divided by x plus 1 and x minus 2. So clearly we've got a linear divided by a quadratic, and because it's already factorised for us, first thing before I do this integral, I'm just going to think about how we can split it up into 2 separate fractions. So we start by saying x minus 5 divided by x plus 1, x minus 2. I use 3 equals to say it's equivalent, but you can write it as just equal to. But essentially this means that this is the same for every value of x, which is actually quite important with this technique. So we're going to have to write it as something over x plus 1 and something over x minus 2. Now, there's a couple of techniques we can use. One's called equating coefficients. We'll show you that later in the year. For now, let's just do the partial fractions technique. And the way that we do this is we want to compare the left-hand side with the right-hand side. And you can't compare these two separate fractions with one fraction. So the first key step is to multiply throughout to get rid of all the fractions. So let's multiply by x plus 1 and x minus 2. So we'll say x minus 5. Now if I multiply the right hand side by x plus 1 and by x minus 2, the x plus 1 would cancel, so a would be multiplied by x minus 2. b, remember we're multiplying by both of these terms to get rid of all of our fractions. So if we multiply by x plus 1, b is being multiplied by x plus 1. And if you multiply by x minus 2, they would cancel. So this is what we're left with. With a bit of practice, you'll quickly jump to this step, and then this is what we use to basically figure out what a and b are. Once we've found what a and b are, we can actually just integrate the two separate fractions. So this works for any value of x. Now you just need to look at it and essentially pick like a suitable number to sub in. I'm going to say let x equal minus 1. Because if I substitute minus 1 in, that bracket there would become 0. So that disappears. If that bracket disappears, you can figure out what a is. Because remember, all we're trying to do now is figure out what a and b are. So if we let x equal minus 1, let's substitute it in. We'd have minus 1 minus 5, so that'd be minus 6 would equal. So minus 1 is this bracket, minus 1 minus 2 would be minus 3, so minus 3a. And the whole point that we did this, if we let x equal minus 1, that would become 0 times b. Sometimes I write plus 0 just to clarify that that bracket has disappeared, which is why we've chosen minus 1. So therefore, a would equal 2. And let's let x equal, see what the next value would be. We've figured out what a is. Now we need to figure out what b is. So if we want this bracket to disappear, if we substitute x equals 2 in, that would become 2 minus 2, so that would disappear. Let's let x equal 2. So we'd get 2 minus 5, which would be 3. Sub it into this, that becomes 0. Sub it into this, so 2 plus 1 would be 3b. So b would equal 1. Oops. So once we've figured out the value for our two constants, now we can go back and look at this integral here, okay? So we know that x minus 5 divided by x plus 1, x minus 2 is exactly the same as 2 over x plus 1 plus 1 over x minus 2. Okay, so very often partial fractions is like the first part of a question in an exam. Like if it asks you to express something in partial fractions, like split it up, the reason is you can pretty much guarantee that after you've split this fraction up, you can then do something much easier with the two separate fractions. So this integral that we're being asked about is the same as integrating these two. Instead of integrating this thing, we can integrate these two separate things. Let's integrate 2 over x plus 1. I think it's really useful if you write them as two separate integrals. Okay, now we're thinking, all right, derivative on top, this is a fraction. So if I differentiate, I get 1 instead of 1 on top. Not quite, I'll change that in a second. If I differentiate, I get 1. Yeah, this one straight away works. So all I've got to do with this, save me writing it all out again, that 2 is a multiple of 2, which you can just take outside. Like 2 on top of the fraction is like 2 times 1, isn't it? So we could write that as, oops, 2 times 1 over x plus 1. And we've got it in the correct form. So this would be 2 ln modulus of x plus 1 plus ln modulus of x minus 2. Let's see. I appreciate there's quite a lot going on there, guys, because that's the first time you've seen partial fractions and then the integration combined. The integral we've done the last couple of weeks, haven't we? But it's just getting to that point. So we will need to practice a few of these. Essentially, the first step is to realise that this fraction, we need to split it up, multiply up, sub in a suitable number, and then when you've figured it out as two separate, you can just integrate them both separately. A little bit more going on with this next example. So essentially what we've got now is we've got a quadratic divided by, just look carefully at that denominator, it's a cubic, isn't it? Because there's a bracket squared, so that'd be a quadratic. Sounds big. So we've got a cubic dividing it into a quadratic. So it's not top heavy. However, the form for this one is going to have to be something over 2x plus 1. Plus, now when you get a bracket squared, I will explain why this happens when we're back in class, but for now, just trust me on this one, right? If the bracket's squared, you're going to need something over x minus 2 and something over x minus 2 squared. So there's actually two separate fractions which we can add together and they would look like this denominator. Okay, now once we know what the form is, we want to get rid of all these fractions so we can compare the left hand side with the right hand side. So I'm going to have to be careful to do this. I've got x squared, 8x squared minus 19x plus 1. Now if I multiply by 2x plus 1 and x minus 2 squared, I'm multiplying everything by this denominator, because then it'll cancel all my fractions. 2x plus 1, so 2x plus 1, they'd cancel, and that would be left with a times x minus 2 squared. The one that people sometimes get wrong is this one, so just be careful, right? b is already over x minus 2, so if I multiply up by x minus 2 squared, it still has an x minus 2 with it, and it also has to be multiplied by the 2x plus 1. c is over x minus 2 squared, so if I multiply by x minus 2 squared, they cancel, but it does have to be multiplied by 2x plus 1. Okay, so what could we let x equal? Look at this equation that we're left with, like it's a mess, isn't it? There's x's all over the place, there's a's, there's b's, there's c's. We could expand all this out and compare, but it's easier if we just say, well, this is true for any x value, so let's let x equal 2, that'd be a good place to start, wouldn't it? If I let x equal 2, the x minus 2 brackets disappear. So if I sub it into the left hand side, I'll end up with minus 5. And then when I sub it into the right hand side, that disappears. That one disappears because it's b times that bracket, which is 0. So as soon as one of your brackets is 0, all that stuff times together becomes 0. Because anything multiplied by 0 disappears, and then 2 times 2 plus 1, so 5c. So minus 1 equals c. What else could we do? Let's let x equal, okay, so 2x plus 1. Remember, you want this to disappear, so you could rearrange it if you want, like when does 2x plus 1 equal 0? You can see that we're going to need to use minus a half. So if we let x equal minus a half, and we sub it into the left hand side, I'm going to get 12.5. Sub it into the right hand side. Now be careful when we sub it into this. Okay, so minus a half, minus 2, and then squared. So a would be multiplied by minus a half, minus 2, so minus 5 over 4 squared. And you square the negative, it becomes positive. So that would be 25. over 4. Solving this will give us a equals 2. Okay. Now there's a little problem here. We need to figure out what b is, don't we? Because when we sub in, both of these brackets disappear. Now don't forget, this whole equation is true, so we can put any number in we want. To figure out what this last value is, I'd just always let x equal 0 if you want. You can let it equal any number with 0 if you haven't used 0. 0 is a good one to use. If you substitute 0 into this, look what happens. We get 1 equals minus 2 squared 0, so that'd be 4a. 0, so minus 2, 0, so that'd be 1, minus 2 times 1, so that'd be minus 2b. 0, so that'd be plus c. And we know what the other two values are, so that'd be 1. If a is equal to 2, that'd be 8 minus 2b plus c, which is minus 1. So if we rearrange this, we'd get 7 subtract 7 minus 6 equals minus 2b. So b would equal 3. Okay, quite a lot going on again. You might want to pause and just watch that bit again. But now we've done most of the work. Okay, so instead of this horrible fraction that we couldn't integrate, we know that this is the same as 2 over 2x plus 1 plus b, which is 3 over x minus 2, plus c, which is minus 1 over x minus 2 squared. So this integral here that we were originally asked about is the same as integrating these separate fractions, which is much more easier to integrate. Okay, so I would recommend writing them as 3 separate fractions because it's 3 separate integration questions. Okay, for the first one, differentiate, and you get 2, and 2's on top straight away, so that's just going to straight away become an ln. For this one, if we differentiate, we get 1, so we've got a little bit of work to do with the 3. We can take the 3 outside, and 3 times 1 is the same as the 3 that we started off with. The last one, be very careful. This is not an ln integral. Like if you differentiate, this is a quadratic. If you differentiate this, you don't get minus 1. It's never going to be a derivative on top. This is a bracket to a power, and it is linear. Okay, so we can think about this. Take the minus outside. You're integrating x minus 2 to the power minus 2. So this is just a reverse chain rule. Like it's a bracket to a power. We can integrate this. Okay, so we are going to end up with this one straight away works, so that would just be ln modulus 2x plus 1. This one we have to take the 3 outside, so that would be 3 ln modulus of x minus 2. This one, remember the rule for a bracket to a power, and there's a minus. Add 1 to your power, so that would be x minus 2. Add 1 to the power, so we get minus 1. Divide by the new power and the coefficient, which in this case is just 1. Okay, so tidying this up, we would get ln 2x plus 1 plus 3 ln x minus 2 minus minus becomes plus, so that would be plus. That bracket to the power minus 1, I'm just going to write it as 1 over that bracket. And then don't forget plus c. Okay, one more. This one's a lot quicker than the last one, so don't worry. Okay, just to notice that our denominator is a difference of 2 squares. So we could write that as 1 minus x times by 1 plus x. So the first task for this integral is to realise that we can, before we integrate it, we can rewrite it. So I'm going to say, 2 over 1 minus x squared is equivalent to something over 1 minus x plus something over 1 plus x. Okay, multiply up. Don't forget that 1 minus x squared. I'm actually going to write it as 1 plus x, 1 minus x, just to make it a bit easier. It's the same thing, isn't it? So if we multiply up by this to get rid of our fractions, 1 minus x cancels and you're left with a times by 1 plus x. 1 plus x cancels, so you're left with b times by 1 minus x. Let's let x equal 1. So 2 would equal 1 plus 1, 2a, plus 0. A equals 1. Let's let x equal minus 1. So 2 would equal 1 minus 1, so that would be 0. And then we get 1 minus minus 1, so that would be 2b. So b would also equal 1. So we are just integrating, instead of this integral, we're integrating 1 over 1 minus x plus 1 over 1 plus x. This one, differentiate, you get 1, yeah, 1's on top. This one, differentiate, we get minus 1, so we want a minus 1 on top. So just write it as minus minus, so you get your derivative on top. And then finally we get minus ln modulus 1 minus x plus ln modulus 1 plus x plus c. The final answer might be written in a certain form. Don't forget, the last thing is you can group the logs together. So if you've got a log minus a log, that one there, 1 plus x, and then the one that you're subtracting, you divide them by this one, so that'll be divided by 1 minus x. Let's see. Okay, conscious that this is quite a long video, guys, so I'm going to stop that one there, and then I'll do another new video on the top heavy ones. There's just two examples to do for the top heavy ones.